All right, starting this new unit, we're going to be talking about matter. This kind of starts in the middle of the packet, but we're going to jump around in this packet a little bit anyway. So matter is anything that has mass, which means that it has weight, and it takes up space, which is just a fancy or a non-fancy way of saying volume. So anything that has mass and volume is matter. Matter can be broken down into elements and compounds. Element is a pure substance made of only one type of atom. And of course, you've got all the elements on the periodic table. An atom is the smallest unit of an element that maintains the properties of that element. Atoms can be broken down into smaller parts, but they can't be broken down chemically. So we can also only break compounds down to the level of the atom. Compounds are substances that are made from the atoms of two or more elements that are chemically bonded. And in this second half of the year, or the course, we're going to be getting into bonding and a lot more about the actual chemistry and why the chemistry happens. When we have two atoms that are bonded together, we call that a molecule. It's the smallest unit of an element or compound that, again, retains all the properties of that element or compound. Compounds can be amazing. We've got two molecules here, or two atoms. Let's say that one of them is Na and the other one is Cl. So what we have here is we've got table salt. NaCl is salt. Now, if you look at just the properties of Na, it's right here on the periodic table. It's a metal. It's a metal that's very, very reactive. In fact, it's so reactive, if you were to take a piece of sodium and put it in your hand, it would start to react with the water vapor that's in the air and the water that I have on my hand. It would start igniting, sparks would fly all over the place. It would begin to burn. It would actually burn through my hand and fall onto the floor where it would continue to burn. It's highly reactive, especially with water. And of course, our bodies are made of mostly water. The other part of salt is chlorine, Cl. Chlorine is a gas at room temperature, and it's deadly. You cannot breathe chlorine gas in and live. So we basically have two deadly elements, sodium and chlorine. But when we put them together, and Cl, we get salt, table salt. Not only does it taste good, but our bodies actually need it in order to survive. We need to have salt in our bodies to make sure that we've got the right. Salts are a type of electrolytes. So to keep our heart working, to keep our muscles working, we have to have electrolytes. But either one of those things by themselves is deadly. Now, some elements cannot exist on their own, and they're known as diatomic elements. Di means two, atomic. So they're diatomic elements. And that makes their smallest unit a molecule instead of an atom. So you can write this down and remember it this way. Br, that stands for bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. These are all they only exist in nature in pairs, which is why when we balanced chemical equations, if we had oxygen, it was always O2. If we had hydrogen, it was always H2, and so on. These are all diatomic elements. I would put a box around these because you need to memorize the diatomic elements. The best way to do this is the word Brinkelhoff. If you read these letters and put it together into a silly word, you get Brinkelhoff. I will say Brinkelhoff a bunch of times to remind you about the diatomic elements. If you're looking for them on the periodic table, most of them are nonmetals. Nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Hydrogen is over here. Hydrogen sometimes can't make up its mind whether it wants to be a nonmetal or a metal. It has one proton, so it belongs in that first column. So these are the diatomic elements. There are other ones you can see here. Phosphorus. likes to exist in groups of 4 atoms together, and sulfur likes to exist in groups of 8 atoms together. So these are diatomic elements, exist in pairs, and there are other polyatomic elements like phosphorus and sulfur. I wouldn't expect you to memorize those. I do expect for you to know that Brinkelhoff lists the diatomic elements. All right, moving right along, we've got physical properties. Physical properties relate to a substance's physical nature. I like to think of these as being things that are descriptive, things like color. Maybe something is shiny. It could be an actual property like boiling point. Water's always going to boil at 100 degrees Celsius. On the other side of that, we could have freezing point. Water will always freeze at 0 degrees Celsius. So we've got color, shiny. We could include in that odors. If something smells a certain way, that would be a physical property. Chemical properties relates to the substance chemical nature. Usually what the substance will react with. Like, does it react with oxygen? Does it combust? Does something rust? And so on. So the chemical properties really are about how does this substance behave chemically? Now, the next thing is, does a substance change as the amount of matter changes? An extensive property depends on the amount of matter present. Usually these are things we're going to measure, like volume, or mass, length, width, and so on. All of these things depend on the amount of matter that's present. Intensive properties do not depend on the amount of matter present. Intensive properties to me are physical and chemical properties. So if I'm going to list intensive properties, it would be color. Maybe it reacts with oxygen. That would be a chemical property. Another intensive property would be it has a melting point. At a specific temperature and so on. So physical and chemical properties really are intensive properties. Extensive properties are things that depend on the amount of matter present. And in class, we did some different examples. So I'll give you just a couple of them here. So burning, and let's just say I'm burning wood. The definition of burning wood, it's a type of combustion, which goes back to our types of chemical reactions. Combustion was one of them. And combustion is when you have a fuel reacting with oxygen, and that will yield carbon dioxide and water. Combustion. Now, is this intensive or extensive property? So if you're burning wood, it doesn't matter if the piece of wood is large or if the piece of wood is small. If it's wood, it will combust. So it doesn't depend on size, so that's intensive. It's a chemical property. Another example would be, let's see. Let's go with melting ice. When we're melting ice, we have what's called a phase change. And we're going from solid to liquid. So when it's going from solid to liquid, The volume and the mass is staying the same, so it can't be extensive. When it's changing phase from solid to liquid, that's just melting. So that would be an intensive property. And there's no chemical change. We're starting with water, just in a solid form. We're ending with water in a liquid form, so that's a physical change. It's just changing form. Again, it's relating to the substance physical nature, physical property. It's a physical change. Let's try another one. How about cooking an egg? What's happening when we're cooking an egg is we've got heat that is changing compounds. It doesn't matter if the egg is big or small, it's still going to cook, so that would be another intensive property. Now, if the heat is changing the compounds, then we have a chemical change. Let's do one more. Let's do, ripping paper. When we're ripping paper, we're altering the paper's dimensions, or altering the size of the paper. So intensive or extensive, well, we're basically changing the length of the paper. So that's going to be extensive. Paper started off as paper. It's going to end as paper, just a different size. So that's going to be a physical change. No chemical reaction took place. So there are some examples of intensive and extensive properties, physical and chemical changes. After this, what we did is we went into classroom and we tried the QIA, physical and chemical changes, and it's just kind of a little practice for you, and it'll even tell you if you're right or wrong. Next part we did in our notes was to just talk for a few seconds about safety data sheets. At this point, you normally would have been exposed to a lot of these, and I would have been talking about different safety hazards. But what you're looking for here in the material data safety sheet is the little diamond right here. And that's going to describe any hazards that there might be present with a certain chemical that you're dealing with. If you see a 2, you can see here that it's hazardous, which means it's a health hazard. This is going to be something that you need to worry about hurting your own physical, your body. Okay, these would be things like poisons, things that will burn you, and so on. Fire hazards, that's will this suddenly combust? Will this, as it's just sitting there, start on fire on its own? If you see a 4, this is very combustible, which means it can start on fire on its own at temperatures below 73 degrees Fahrenheit. So that's something that's going to be very dangerous to or very dangerous to handle. Blah, can't talk today. The yellow diamond is instability. How likely is this substance to explode? Well, if you see a 1, that means it's going to, if you heat it up, it will become unstable. 0 would mean it's stable. The last one, the white part of the diamond, would be a specific hazard, like maybe this is an acid, and it would just state that it's an acid. Next to the symbol, you should see what kind of protective equipment are used or needed to be used when you're using this. Maybe safety glasses, gloves, and a full suit. So physical change, jumping back into physical and chemical change. A physical change, the big thing to remember with this is that a change in a substance that does not result in a change of the identity of the substance. We're starting with one thing and we're ending with the same thing. Here's some examples of some changes of state, otherwise known as phase changes. So if it's going from liquid to solid, that's freezing. If it's going from solid to liquid, that's going to be melting. If we have a gas that's going from the gas state to the liquid, that's going to be condensing. If we have a liquid that's going to a gas, that's going to be boiling or vaporization. Vaporization, we're going to use that term mostly. The last ones are going straight from gas to solid, which is called deposition, or something going straight from a solid to a gas, which is called sublimation. Chemical changes are when a change in when one or more substances are converted into different substances with different properties. The example is carbon combined with oxygen will give you carbon dioxide. I also talked about salt molecules above, where you've got sodium combining with chlorine to produce salt, NaCl. There are 5 different signs of a chemical change. Number 1 is bubbling or fizzing. Basically, a gas is being released. Number 2 is a solid is formed. When mixing two liquids. The other name for this is a precipitant. That's a solid that forms when you're mixing two liquids, is the precipitate. Number 3, you've got color change. If you do a chemical reaction and you see a color change, that's a sign that a chemical reaction has taken place. Number 4 is heat produced or lost. And number 5 is you've got a change in odor. Something smells different. And that right there is where we stopped for the day. So that was the end of Monday, the 19th.